This is the brief on magnetic forces and material deformation. We're going to dive into the mathematical link between the forces happening inside a material and the actual physical stress on its surface, the stress that dictates how it changes shape. So first, how do we even measure it? See, the magnetic forces spread all throughout the material. To figure out the physical effect, we use something called the Maxwell stress tensor. It's this crucial tool that converts that widespread internal force into simple, measurable stress components right on the material's surface. Second, this magnetic stress is really a mix of two things: tension and pressure. The tension part comes from what we call the shear term, and physically, this is what causes the material to stretch out, pulling the object precisely along the direction of the magnetic field lines. Finally, you've got the compression. This comes from the pressure term, and it acts like a uniform squeeze, pushing the material inward, but perpendicular to those field lines. So you get this stretch along the field and a squeeze across it, all at once. And that's what creates that classic football-shaped deformation. The Maxwell stress tensor gives us the math to find the force, and its two components explain the tension and compression that physically reshape the volume.